Okay, so let's try another problem, and let's ask ourselves, okay, so we have two lines. We have y which equals x, which just has a slope of 1, and y which equals 2x, which is a slope of 2. Okay? And then its boundaries, which would be these lines, x which equals 1 and x which equals 2. Now let's ask ourselves, which would be better? Integrating with respect to x first, or integrating with respect to y first? Okay. Now, if I was going to integrate with respect to x first, let's see what would happen. I would have to consider, that's supposed to go all the way up to 2. I would have to consider integrating from this line all the way over to that one. And then I'd have to consider integrating from this line all the way over to that one. So it would require multiple integrals to actually begin by integrating with respect to x. But if I consider integrating with respect to y, I'm just going from one line to the next. Okay? So having the inner integral as an integral with respect to y, it's going to make the problem easier. Okay? So normally whenever you're trying to consider which direction to integrate in, at the beginning, just go ahead and draw an arrow going in. This is going to apply to triple integrals as well when we start considering integrating to a surface. We're going to actually draw a line within a plane going to a surface or something like that. And so this guy is going to be our best bet. Okay, so we want to integrate with respect to y first. Okay. So in our x domain, where are we going? 1 to 2. So this is going to be the integral from 1 to 2. Okay. And then we're going from x to 2x. Of x squared y dy dx. Okay. So remember, we're integrating with respect to y, so let's just treat the x squared as a constant, and let's just integrate the y. Okay. So this would become, okay, so that the integral from 1 to 2, we can leave that alone. And that would be x squared, and then y squared divided by 2. And this is going to be evaluated at x and at 2x, and the integral with respect to x. Okay. So let's leave the 1 and the 2 alone. The integral from 1 to 2, this would be x squared, now times 2x squared divided by 2, and then minus, well, x squared, and then this would become, well, x squared divided by 2, and we have an integral with respect to x. Okay. Okay, so if I square this guy, I'm going to get x squared, and x squared times x squared is going to be x to the 4th. But if I square the 2, I'm going to get a 4. And so 4 divided by 2 is going to be 2, so that's going to be the integral from 1 to 2 of just 2x to the 4th, okay? And then minus x to the 4th divided by 2, and we have an integral with respect to x. Okay, so I can combine these at this point. So you have to think of, what's 2 minus 1 half? Well, 2 minus 1 half is 3 divided by 2. So this becomes the integral of 1 to 2 of 3 divided by 2 multiplied by x to the 4th. Okay? So, dx, of course. Okay? All right. That becomes 3 divided by 2 multiplied by x to the 5th divided by 5 of evaluated at 1 and at 2. It's going to be easiest for me just leaving 3 over 2 out here. Okay, so that becomes 2 to the 5th divided by 5 minus 1 to the 5th divided by 5. Once again, we're going to get into some kind of nasty fractions. That's not too bad though. So, well, what's 2 to the 5th? 2 to the 5th is 32. So, what is this? This is 32 divided by 5 minus 1 divided by 5. So, that will equal 3 divided by 2, and then multiplied by 31 divided by 5. All right, 3 times 31 is 93. And 2 times 5 is 10. And that's probably the cleanest answer we can get. That is the cleanest answer we can get. Before we go on to the next video, hold any questions until I get this video done. Let's say you were just given a region instead of having to try to figure it out. So, let's say we have a double integral across a region, and this is 1 plus 2x plus 2y. Yay, and we're just going to define the region as equaling all of x, y values such that 0 is going to be less than or equal to y, which is going to be less than or equal to 1, and y is going to be less than or equal to x, which is going to be less than or equal to 2y. Now, if somebody just presents you with this problem, what are you going to do? I mean, you can ask yourself, well, which region am I actually going to integrate first? Well, it's already given that x has boundaries as functions of y. So, what does that mean? That means that you're going to integrate with respect to x first. Okay? So, to set up this integral, this would become the integral from 0 to 1, the integral from y to 2y of, let's keep those parentheses, 1 plus 2x plus 2y. Okay? Now dx dy. Okay? So, since you're given that x is bounded by functions of y, that means that you're going to integrate with respect to x first. Okay? So, let's integrate with respect to x. So, we have the integral from 0 to 1. This is going to be x, well, plus x squared, because it becomes x squared divided by 2, so the 2's cancel each other out. And plus 2xy, now this has to be evaluated at y and at 2y, and we're going to integrate with respect to y. Okay, so that's going to become the integral from 0 to 1 of, right, so this first one is going to be 2y minus y, and then plus this is going to be 2y squared minus, okay? And then plus 2 times 2y times y, okay? And then minus 2 times y, and an integral with respect to y. Okay. Okay. So that becomes the integral from 0 to 1. I'll do this in a couple steps. Okay. Well, 2y minus y is y. Okay. Now this becomes 4y squared minus y squared. Okay. So 4y squared minus y squared. This is going to be plus 3y squared. Okay. And then plus, okay, so this is going to be 2 times 2, which is 4, y times y, which is y squared. And then we're going to have, what we're going to have from this guy's going to become 4y squared minus 2y squared. So 4y squared minus 2y squared is going to be 2y squared. Okay, we can do a further combination saying that this is going to be the integral from 0 to 1 of y plus 5y squared. dy. All right, great. We're at a spot where we can actually just integrate this thing. So that becomes y squared divided by 2 plus now 5 y cubed divided by 3, evaluated at 0 and at 1. Well, in this case right here, ignore the 0. Let's just plug in 1 into this. And so if I just plug in 1 squared is 1, 1 cubed is 1. Okay? So now it becomes 1 divided by 2, now plus 5 divided by 3. And after a little bit of multiply this guy by 3 over 3, that becomes 3 divided by 6, multiply this by 2 divided by 2, that becomes 10 divided by 6, so 3 divided by 6 plus 10 divided by 6 is 13 divided by 6. And that is the answer to that problem.